Hey guys, well, welcome to Unit 6. Unit 6 I've titled to the Moon and Back. It's about our Earth, our Sun, and our Moon and how they interact. This is our first attempt at flipping the classroom, so keep in mind, by doing these notes at home, that prevents us from having to do them up here at school. We can now do or have more time to do more fun things, more challenging things, but at the same time, you're going to have those notes that you've already done. You'll be able to refer to those things during class. So take some good and efficient notes. Remember, if any time you need to pause and take notes, this is the perfect opportunity to do that. And remember, if I say please draw something or please label something, you're really going to want to think about doing that as well. All right, guys, let's get into Unit 6 here. Okay, so we have some vocab to start. And the first one is our sun, which is a star at the center of our solar system. This gives the Earth heat. It gives the Earth light. More importantly, it gives the Earth energy so we can sustain life. We have a moon, which is a natural satellite that revolves around our planet or orbits our planet. And then we have the Earth, which is the third planet from the sun in our solar system. We are the only planet that is known to be able to sustain life. When in space. Okay, so more vocab, guys. The word orbit, we saw it on the last slide. This is the path that an object takes as it revolves around another object. Or more specifically, this is the path that the Earth or other planets take to orbit the sun. Rotation. This is when a planet spins on its axis. Okay, so it's the time that it takes for the Earth or any other planet to spin on its axis. For us, that's a 24-hour period. What is an axis? It is an imaginary line around which our planet spins. And lastly, we have revolution. This is the amount of time that it takes an object to orbit another object. So, for example, it takes the moon 29.5 days to completely cycle through or orbit the Earth. It takes the Earth 365 days to completely cycle through or orbit the sun. That's one revolution around the sun. All right, so a little bit more about Earth. Earth, well, we have the cycle. We have a day cycle and a night cycle. Daytime, Earth faces the sun. We get light. At nighttime, we are on the other side. We are away from the sun, so we're not getting light, simply put. Rotation. Well, rotation is what gives us our day-night cycle. Earth makes one rotation on its axis every 24 hours. This gives us our day-night cycle. So 12 hours we're facing the sun. As we rotate around, 12 hours we're not facing the sun. And mixed in those 12 hours is when you get your dawn or your early morning and your dusk and your late evening. Guys, if the Earth were to spin a little bit faster, then it would be a quicker day, much quicker. If the Earth were to rotate a little bit slower, our days would be longer. So again, the rotation of our Earth gives us our day-night cycle. Reflection. We've talked about this when we've talked about light. The Earth reflects the sun's light, just as every planet does, and the moon. Therefore, you can always see the planets or the moon from outer space. All right. Guys, I really would encourage us to play this game. If you'll click right here, both games, you can click on this hyperlink here, or you can click on this hyperlink here. Go play now. It will really extend your knowledge to be able to play these games. All right, the moon, to rotate or to not rotate. As a matter of fact, the moon is a geostationary celestial object, meaning the moon does not rotate. So the side of the moon that you always see is the side of the moon that you will always see. Reflection. Just like the Earth, the light from the sun reflects off of the moon and can be seen at night. Shadows. The Earth casts a shadow onto the moon, creating our moon cycle. So sometimes it's really small, that's a crescent moon, and sometimes it's really big, and that's a full moon. And we'll talk about the moon cycle in our next unit. Lastly, we have revolution. Here's that word again. Just like we make a revolution around the sun, the moon makes a revolution around us, and it takes 29.5 days for the moon to complete its cycle. Lastly, we have craters. Craters are what you see on the moon's surface. It's where meteorites impact the surface of the moon that creates a bowl-like indentation on the surface of the moon. I can't wait for us to do this lab because we're going to use some rocks and we're going to use some flour and it's going to get dirty, guys. All right, so the sun. What about the sun? It gives us energy. It gives us light, not only us, to the rest of the solar system as well. The Earth revolves around the sun, and the Earth's rotation makes the sun appear to move across the sky. You can see that in one of the games that you can play on a previous slide. So again, I'll encourage you to go ahead and play those games. All right. Guys, at this time, I'd like for you to press pause, and I'd like for you to draw this Venn diagram. It compares different things from the sun to the moon and the earth, and it also compares how the sun and the earth are similar. It also compares how the earth and the moon are similar. And lastly, it'll compare how all three of them are similar. All right. One big thing that you can do with models, or big thing you can do with space is to create models. Obviously, you can't recreate things that happen and occur in outer space. They're just way too big. So models are the way to go when you're talking about space. They can be very effective. Models can show you how something works or what a process looks like from start to finish. And they have their advantages as well. Models are great examples of hands-on experiences, getting to see firsthand what something you may be able or may not be able to see otherwise, what it really looks like. Models also have their disadvantages, and usually that disadvantage has to do with the model being outdated, or models are not scaled to actual size, so they're much smaller, kind of like your model planes or your model boats or cars or things like that. They're much smaller than the actual thing. Okay, guys, lastly, I want us to just take a review. Models, try it at home. This is your day-night cycle. Try this at home, guys. I want you to get a flashlight, okay? And then I want you to get a globe. Take the flashlight, shine it on the globe, spin the globe around, guys, and you'll come up with the day-night cycle. Look at each continent, each hemisphere, each side of the earth as you do it. That's a good model to look at and review your day-night cycle. All right, guys, here's your review. Solar system, you did it in 3rd grade, you did it in 4th grade. We know there are 8 planets. There's an asteroid belt. There's 4 inner planets, Mercury, Venus, Earth, and Mars. There's 4 outer planets, also known as the gas giants. There's Saturn, there's Jupiter, there's Uranus, and there's Neptune. Okay, guys, I hope you enjoyed this video, and we'll see you in class on Friday. Remember, this video is due next Tuesday when we come to class. Have your notes ready to go. All right, guys, thank you so much, and I'll see you tomorrow.